Azure Command Line Interface, CLI, and the Azure Python SDK for machine learning. Installation of Azure CLI. The Azure CLI can be installed on various systems, providing flexibility for C/CD systems like Jenkins or GitHub Actions. Installation on Windows can be done using an MSI installer, and users can verify the installation by checking the version. Using Azure CLI extensions. Users can install extensions, such as the Azure Machine Learning extension, to enhance CLI functionality. The command Oz extension list can be used to verify installed extensions, and the OzML help command provides information on available commands for managing Azure machine learning resources. Authentication and account management. Interactive authentication can be performed through a web browser, and sensitive account information is returned in JSON format. The command Oz account list allows users to view their Azure accounts and subscriptions. Installation of Azure Python SDK. A virtual environment is created using Python to manage dependencies, followed by the installation of the Azure ML Core library. Users can verify the installation by importing the Azure ML module in Python, ensuring it is sourced from the virtual environment. Azure ML Studio with Python. Setting up Azure ML. The process begins with installing the Azure ML Core Python SDK and setting up necessary credentials like subscription_ID and service principal details. Users can authenticate using a service principal or through dynamic login if they only have the subscription ID. Creating a workspace. Create a new instance of Azure Machine Learning Studio and set up a workspace. Upon successful creation, various resources such as storage account and key vault are deployed. Managing compute resources. The next step involves creating compute targets and clusters, specifically a CPU cluster with defined configurations. Important to emphasize the importance of monitoring resource usage to avoid unexpected costs. Cleaning up resources. Finally, the content highlights the need to destroy the workspace and resources after use to prevent overcharges. It concludes with a reminder to check the Azure portal for the status of created resources and ensure they are removed when no longer needed. Hugging Face Transformers. We focus on using Hugging Face's transformers for machine learning tasks, particularly in a Jupyter Notebook environment. Installation and setup. Hugging Face provides APIs and packages for various machine learning tasks, including text, images, and audio. The transformers library is installed via pip, and it's recommended to use a virtual environment. Using the pipeline. The pipeline helper is used to interact with models, allowing for tasks like text summarization and sentiment analysis. Models are loaded dynamically, eliminating the need for local files, which facilitates exploration. Model capabilities. The text-to-text model can summarize text and perform sentiment analysis, as well as answer questions and translate between languages. The GPT-2 model can generate text based on an initial phrase, showcasing the dynamic loading and interaction capabilities of Hugging Face models. Hugging Face datasets. Hugging Face datasets overview. The library allows users to retrieve datasets stored on the Hugging Face hub, similar to how GitHub functions for code. It provides access to a wide range of datasets, with over 9,000 available, including popular ones like Amazon reviews. Loading and using datasets. Users can load datasets by name using the load_dataset function, which simplifies the process of accessing large datasets without storing them in local repositories. Datasets are automatically split into training, validation, and test sets, making it easier to manage data for machine learning tasks. Integration with pandas. The library allows users to convert datasets into pandas data frames for easier manipulation and analysis. This integration facilitates data exploration and pre-processing, which are crucial steps in the machine learning workflow. Azure Open Datasets. The content focuses on Azure Open Datasets and how to utilize them effectively in Python for MLOps. Overview of Azure Open Datasets. Azure Open Datasets allows dynamic loading of curated datasets, similar to Hugging Face. It includes extensive documentation and examples, making it easier to interact with various datasets. Getting started with Azure Open Datasets. To use Azure Open Datasets, you need to install the AzureML Open Datasets package, specifically version 1.44.0. The installation requirements are outlined in a requirements.txt file. Exploring datasets with Python. Hugging Face offers a large variety of datasets via the datasets library, which includes data for NLP, computer vision, audio, and multimodal tasks. Below is a categorized list of some popular datasets available through Hugging Face. Natural Language Processing, NLP. Text Classification. 01. AG News. News Topic Classification. 2. IMDb. Movie Review Sentiment Analysis. 3. Yelp Review. Reviews for Business Sentiment Classification. Part 4. DBApedia. 14. Ontology Classification from Wikipedia. Question Answering Bot 1. Squad V1/V2. Stanford Question Answering Dataset. 2. Natural Questions, NQ. Google's QA dataset based on real queries. 2-3. Trivia QA. Large QA dataset collected from trivia websites. Machine Translation.on. WMT14. Translation datasets, for example, English-German. 2. Easult. Translated TED Talks. 3. Flores 200. Multilingual translation across 200 languages. Named Entity Recognition. NER. 1. Co-NLL 2003. English NAIR dataset. PR Lock, ORG, miscellaneous. 2. ENUT 17. Emerging and Rare Entity Recognition. 3. Onto Notes 5. Rich linguistic annotations, including NAIR. Text summarization. Bon on. CNN/Daily Mail, news articles and summaries. 2. Exum. Single-sentence summaries of BBC articles. 3. Multi-news, multi-document summarization. Language modeling. Wiki Text 103. Clean Wikipedia data. Open Web Text. Web-crawled content similar to OpenAI GPT-2 dataset. The Pile. Massive dataset used to train large language models. Dialogue. Daily dialogue. Human-written conversations with emotion labels. Persona chat. Conversations conditioned on personas. Blended skill talk. Empathetic, knowledgeable dialogues. Using the argparse framework. Using the argparse library in Python to create command-line interfaces for scripts. Creating an argument parser. Bon on. Import the argparse library to utilize its features. 2. Initialize the argument parser class and provide a short description of the program, which will automatically generate a help menu. Adding command-line arguments. Bot. Use the add_argument method to define flags, such as sort, which can be set to store_true to indicate a Boolean value. 2. This allows users to enable or disable features in the script through command line options. 3. Testing the command line tool. 4. Run the script in the terminal with the H flag to display the help menu, showing available options. 5. Check the value of the flag by printing it, demonstrating how the argparse library manages command line arguments effectively. Declaring dependencies. The content focuses on declaring dependencies in a Python project, particularly using a requirements.txt file. Understanding requirements.txt. The requirements.txt file lists package names along with their version numbers, where == indicates a pinned version. If no version is specified, the latest version of the package will be installed. Setting up a virtual environment. A Python virtual environment is created to manage dependencies, using commands like python env_name and source env_name/bin/activate. The command pip install a requirements.txt installs all listed packages and their dependencies. Pinned versus unpinned environments. A pinned environment specifies exact package versions, while an unpinned environment installs the latest available versions. For example, using pip install pytest installs the latest version, whereas specifying a version pins it to that specific release. Using the click framework. Creating a click command line tool. Import click and set up a virtual environment to install it. Use decorators to define a command and add an argument for the file path. Handling arguments and options. 1. Replace sys.arguf with clicks argument handling for better usability. 2. Implement a path argument that checks if the specified file exists. Adding Boolean flags. 1. Introduce a Boolean flag for sorting options using clicks option decorator. 2. Enable or disable sorting by adding a flag and passing it to the main function. This summary highlights the key steps in building a command line tool with click, focusing on argument handling and flag implementation. Packaging your project. Defining dependencies. Use the install_requires line in the setup.py file to declare project dependencies like click and colorama. You can specify versions for dependencies, but it's optional. For now, they are left without specific versions. Creating command line tools. Bot on. Define entry points in the setup.py file under a console_script section to create executable commands. 2. For example, you can set up a command called geoformat that links to a specific function in your main Python file. Installing the tool. Bot on. Use the command python setup.py develop in a virtual environment to install the tool for development purposes. This allows you to run the command directly in the terminal, confirming that the tool is correctly packaged and available. Packaging. In Python packaging, entry points are used to define interfaces between components, especially for 1. Creating command line tools. 2. Plugin systems. 3. Dynamic discovery of components. They're declared in the setup.py or pyproject.toml with newer build systems, and allow your package to expose functionality to the outside world in a standardized way. Flask. Introduction to Flask framework. Flask application basics. Flask is imported after installation, and an app object is created, typically named app. A decorator is used to define routes, allowing specific functions to handle requests to those routes. Error handling in Flask. Errors can be simulated and handled using the abort function, which allows passing HTTP status codes and optional error messages. The application can be run locally on a specified port, with debugging enabled for development purposes. Running the application. The application is executed using Python and a virtual environment is set up for dependency management. The application can be tested in a browser, with responses indicating successful handling of requests or errors. ONNX is a standard for representing machine learning models that allows models to be used across different frameworks. Serving models with ONNX is a common practice to enable fast, framework-agnostic inference. What is ONNX? ONNX, Open Neural Network Exchange, is an open format to represent machine learning models. It allows models trained in frameworks like PyTorch or TensorFlow to be exported and run in other environments that support ONNX runtime. Why serve models with ONNX? Benefits: 1. Speed. ONNX runtime is highly optimized, often faster than native frameworks for inference. 2. Cross-platform. Use the same model on Windows, Linux, Mac OS, Edge devices. Framework interoperability. Train in PyTorch, serve with TensorRT or ONNX runtime. Steps to serve a model with ONNX. Spot on. Convert model to ONNX2. Install ONNX runtime. Pip install ONNX runtime. 3. Run inference with ONNX runtime. The NVIDIA SMI command allows you to verify the status and usage of NVIDIA GPUs in your environment.